Alright, in this last video of this section we're going to deal with problem number 85. And again, if we want to start off, to show differentiability, we want to show that the limit as x approaches a, in this case a is equal to 2, the limit as x approaches a from the left of f of x minus f of a over x minus a is equal to the limit as x approaches a from the right of f of x minus f of a over x minus a. So in this case, we're dealing with problem number 85. A is equal to 2. So we start out approaching 2 from the left. And based on the definition of the function, when we're approaching 2 from the left, our x values are less than 2. So we're going to be using the top branch of the piecewise function definition. So f of x is x squared plus 1. Then minus f of 1. And f of 1 is 1 squared plus 1. I'm sorry, in this case a is equal to 2, so that should be 2 squared plus 1. And that's all going to be divided by x minus 2. And so we have the limit as x approaches 2 from the left of x squared plus 1 minus the quantity 2 squared plus 1 over x minus 2. Simplifying, you get the limit as x approaches 2 from the left of x squared plus 1 minus 5 over x minus 2. One more step of simplification gives us limit as x approaches 2 from the left of x squared minus 4 over x minus 2, and that factors to be x plus 2x minus 2. The x minus 2 terms cancel, and you get the limit as x approaches 2 from the left of x plus 2. We plug and chug and get 4 as the limit there. So that's the limit as we approach, the limit basically of the secant lines as we approach x equals 2, and that's 4. Alright, then we're going to test to see whether that limit is equal to the limit as we approach from the right. So now we're approaching 2 from the right, and when we're approaching 2 from the right, all of our x values are greater than 2. And so now we're using the function definition in the second branch of the piecewise function. So f of x is 4x minus 3. And f of 2 is going to be 4 times 2, which is 8 minus 3. And that's all divided by x minus 2. Simplifying, we get 4x minus 3 minus 5, which is just 4x minus 8. And if we were to factor out a 4 from the numerator, we would see that our x minus 2 terms cancel, and we are left with 4 times 1, or 4. And so again, the derivative, or the limit of the derivative as you approach from the left, is equal to the limit as you approach from the right, and so the function is differentiable at 2. And what that would look like is the left-hand side of it would be a parabola that is x squared but just shifted up 1 unit, but we're going to follow that parabola all the way over to x is equal to 2, and then from that point on it becomes a straight line, 4x minus 3. And even though one is a parabola and one is a straight line, they make a perfectly smooth transition from one slope to the next, and so it is differentiable at the point x equals 2, or at the x value x equals 2. All right?